So a linked list is basically, denoted like this. So this is 1, this is 2, and this is 3. Okay. So a linked list basically has two things. One is that it has, the data, and this whole block is known as a node. Okay. So a linked list basically is a collection of the nodes, and a node has a data, and at the same time, the node has a pointer to the next node. This is what the linked list data structure is. What is a linked list? A linked list is nothing but a collection of the nodes, and each of the node will have a data. Right, for example, 1, 2, and 3 is a data in the linked list, and each of the node will know a direction, like where the next node is. So the one node knows where the 2 is, 2 nodes where the 3 is, right? So one doesn't need to know where the 3 is, because every node has to know only the next node location, and the next node will know the next node location, right? So the one knows where the 2 is, and the 2 knows where the 3 is. Okay. And there are a few nomenclatures that we follow in the linked list. So the first node, which is 1 here, will be known as the head. Okay. And the last node, which is right now indicating 3, which is 3, will be known as the tail node. Okay. So a linked list is what? A linked list is basically a collection of nodes. Each of the node has two things. One, it has the data, and another, it has a pointer to the next node. The beauty of this is that now, since each node knows where the next node is, then they don't need to be stored contiguously, right? So for example, if suppose this is my memory space, so the first node can stay here, the second node can stay here, the third node can stay here, the fourth node can stay here, right? And the first node knows where the second is, second node knows where the third is, and third knows where the fourth is. So whatever the fragmented memory it is, however the fragmented the memory it may be, right? If if we have enough space to store like 4 nodes of the data, the linked list can fit in, right? And as you said, this is the starting node, so this is known as the head, and this is the last node, so this is known as a tail, right? And why we are calling it head and a tail? So the name has been taken, the motivation has got from the snake itself. So the snake can modify their shape, crawl according to the area in which they move in, right? And they also have a head and they also have a tail. Similarly, the linked list is a snake like a data structure which can crawl itself in whatever space that you put in. Okay, so the first one is known as the head and the last one is known as the tail. So the tail node will always point to the null. So the next pointer to the tail node will be null. So it means that it is not pointing to any other node, right? So this is what a basic linked list data structure is. It normally helps you to answer those questions which was unanswered by the arrays, or it is used in those cases where the array cannot be used because of the fragmented memory, right? Another advantages of the array of the linked list is that the adding a new element is very simple. It's a constant time complexity operation, which was not possible in the case of the array. Also in the array, the deletion was a very expensive operation. Again, we will see in the linked list that if we do the deletion, it's a achievable operation, right? Make sense? So far so good, guys?
Yeah.
Perfect. So let's try to define what linked list is. Okay, so since this is the first class, we'll try to define the data structure. So a linked list is basically a collection of the nodes, and we call it the list node. So I'll define class list node. I'm trying to write the code in Java, and if you guys are not comfortable in Java and want to do it in any other language, just you can transform it the same thing into any other language. Feel free to do it. So you can solve the question in any language that you want. I'll prefer Java because Java is the most common language and it is being used across the industry. So Java will be our medium of instruction. But if you are comfortable in other language like JavaScript, Python, C#, or any other language as such, feel free to modify this code in your language. Select list node. So as I said, the list node has two information. One is private int data itself, and another one is private list node next. So basically a list node has two information. It has its own data and it has a pointer to the next node. So I'll just go and create a constructor for this public. Since these are the private variables, so I go and define the setters and getters. You guys are clear what setters and getters, I understand, right? Everybody? Jahid, you know what setters and getters are?
Yes, sir.
Perfect. So this is how we define our list node. And then let's try to define a class linked list. This is very simple. I will try to quickly go through it, then we'll directly come to the problem space. So a linked list basically, now again another thing. So since in the case of the arrays, you might have seen that whenever you have to pass the array, you have to pass the complete array, right? But in the case of the linked list, since every node knows the next node location, if we just pass the head to any method, it is equivalent to passing the complete linked list, right? I'm again repeating. In the case of the arrays or any other data structure, you will see that you have to pass the complete data structure, right? But in the case of the linked list, instead of passing the complete linked list, if you just pass the head of that linked list, one single node, which is the first node of that linked list, so it is equivalent to passing the complete linked list, a collection of all the nodes, right? So normally in the linked list problem, you will see that every methods we pass only the head node of the linked list to solve any problem, whether we are traversing it, whether we are printing it, we're finding the length, anything like that, right? So basically, the linked list will have just one starting node, which is head. Okay. Now the linked list class have several basic, methods. So this method will remain common across any move. So for example, every data structure that you create, you should know how to iterate it. You should know how to traverse it. You should know how to find the length of it. You should know how to add element to it. You should know how to delete element from it, and you should also know how to update element to it. So basically, a CRUD operation on that particular data structure, you should be able to do it. So we'll be doing the same thing in the linked list, then we'll be doing the same thing in the array, in the stack, then the queue, then binary trees, then all the different kind of trees that we'll be covering about, then in the graph, and then in the priority queue, right? So any data structure that we go and read from now, we'll try to create our first, we implement that data structure, and in those implementation, we'll provide all the CRUD operation that we can do on that particular data structure.